Hello again, and in this recording I'll be solving an exercise related to a prime number. So the problem is we need to write a program that reads a positive integer, so it should be positive, and we need to rewrite it as a sum of two prime number if it's possible. So for example here 16, it could be written as a sum of two prime numbers, so 3 plus 13 is equal to 16, and also we have another pair which is 5 and 11. So both of these numbers is prime number. So the output, so they are telling us that if the number n can't be expressed as the sum of two prime numbers, so we print n. And if n can't be expressed as the sum of prime numbers, so we need to print each possibility on a separate line. So numbers are ordered in ascending order according to A. So the first number is A and the second is B. So they are ordered according to A. So they are telling us that you need to loop over A, and A is always less than B. So in order to be A is less than B. So for example here, obviously I will not try A equal to 11 or 13, because in order to A to be less than B and their sum is equal to the number, so obviously I should reach till half of this number. So I should reach half of this number, because A plus B should be equal to n, and A should always be less than B. So obviously I need to check half of this number. So let us think about the problem. So I have the number 16 again. So obviously I need to find pairs A, B, and A less than B, and we know that I need to check half of 16 for A. So I need to check whether, so obviously I can check 1, I can check 2, 3, 4, 5, 6, 7, and 8. So obviously I won't go beyond 8, because if 8 is a prime number, obviously B would be a prime number, and this is the condition where A is always less than B, even if it's less or equal to B. So we know that 8 is not a prime number. So all the possibilities are there. So we have 14, 13, 12, 11, 10, 9, 8. So I will check if 1 and 15 is a prime number. So we know that 1, so if we don't want to consider it as a prime number, or we consider it, we have a problem with 15, because 15 is not a prime number. We have 2 a prime number, however 14 is not a prime number. We have 3 a prime number, and 13 is a prime number. So 4 is not, 5 and 11, they are both a prime number. Those 6 and 10, they are not. 7 is a prime number, however 9 is not a prime number, and both 2, 8 are not a prime number. So how we will solve that? So we know that whenever we are reading a number, I need to check A n over 2 times. So it means we need to loop n over 2 times, because whenever I'm calculating one number, I can get the second number as equal to n minus I. So if n is equal to 16, for the first iteration I equal to 1, I can get 15, which is n minus I. So this is easy. So always it's n minus I, n minus I. So whenever I'm looping, this is for I equal to 1, I will get 15. If I equal to 2, I will get 14. So it's easy to get the pairs if I'm looping half of the times. Next, I need to check whether both, so in each iteration, I need to check both if both are prime numbers. So obviously, if 1 is prime number, I should check if the second is a prime number. So if 1 is a prime number, obviously the second, it could be not a prime number, so I need to check both sides. So again, if I have a prime number, I can check and be sure that it may be a prime number. However, if the first number is not a prime number, there is no need to check if the second one is a prime number. So if the first A, it means if A is not a prime number, so there is no need to check if the second one is a prime number. So, and we know that in order to check whether a number is a prime number, I need to loop from 2 till radical of n. So whenever I'm looping from 2 to radical of n, if one of these integer numbers divides n, it means that the number is not prime. If I didn't find any of these elements that divide this element n, it means I will be sure that this one is prime. So we have already solved this one, the prime number. So what we will do is that we will read the number, we will just create A, which is equal, so we will iterate n over 2 times. So we will have A, we will have B, and then we will check if both are prime. So we will first try to check whether A is prime. So if it's prime, I will check if the second one is prime, if B is prime. And then we will talk about how to optimize this solution. So first I'll be sticking with what we have already covered in class. So I need to read a number. So let's say scanf percentage D. So percentage D address of n. So I need obviously a variable n. So if I want to be sure that it's positive, I can embrace scanf into a do while. So let's do it. Do while. So as long as n is strictly, let's say, or greater to 0, I will repeat the entry. And then I need to loop, obviously, from 2. So I will skip 1 because 1 we don't consider it as a prime number. So I will start from 2. So I will omit this pair till n over 2. So obviously I need a counter because I need to loop. So for I will start I from equal to 2. And I will reach till n over 2. Strictly, it contains the option n over 2. Obviously, I'll be incrementing the counter at each time. So I have, so I, it will tells me the value of A, and n minus I, it will tells me the value of B. So I will print some stuff here in order to be sure that we are understanding what's happening. So printf, I will print A equal percentage D, B equal percentage D, comma, the first one is I, and the second one is n minus I. And I will do a backslash n. So I will just, in our example, I will read n equal to 16, and I will see all the pairs that could be generated. So you cannot use too much of loop, so maybe I will remove this, or maybe we missed some loops, because obviously I need to do some optional loops inside. I will check it. So obviously I need 5 loops, so I will keep this. So it was removed, so do. Oh, let me remove it, it's okay, and I will do some 2 empty loops. So for I equal to 0, I less than 1, I plus plus, so just for to let the compiler pass my code. So I need 5 for loops, so those are my 5 loops. 3 only, so I need just 3, excuse me. So those are my 3 loops. So on the screen, again, so use the operator more often in your code. So I will use printf percentage d 0. So this is just to be sure that I'm compiling with the requirements of the code. So on the screen, okay, I am seeing 2, 14, 3, 13. So as I have explained, so we have 2, 14, 3, 13, 4, 12, 5, 11, 6, 10, 7, 9, and 8, 8. So those are the pairs that I need to verify. So in this loop, I need to check whether A is prime, and then if A is a prime number, I can check if B is prime. So how to check whether A is prime? So we know that I need to loop from 2 until the radical of my number A. So I need to loop. So obviously I need another loop. I will not use the same counter because it will be dependent. So I will not do any modification of this loop. So for j equal to 2, j should be less or equal to square root of the first number, which is equal to I plus j plus plus. So, and I know that if one of these numbers, so if j would divide I, it means A. So if you want, you can say here A, B, and you can at each time replace A by I and B by n minus I if it's more convenient to you. So I will do that like this because it's more convenient to not manipulate I and j at the first time. So I'll start from j equal to 2 as long as I will reach the square root of A, and if j divides, so j is the number, so it's if A modulo I is equal, if a modulo j, sorry, is equal to 0, so if a is divided by any of these numbers, obviously I should say that this number is not a prime. So for that, we'll be using flags, obviously, because I need to do a break. So whenever I found a divisor, I do a break, but before that, so I need to use a flag. So you can not use a flag or use a flag. So if you use a flag, you will check the flag. Otherwise, you check whether you have reached square root, yes or no. So if you don't want to use a flag, so we know that I have exited the for loop here normally. It means that I didn't executed the break instruction. Otherwise, if I have executed the break, it means that I will not reach the end of this loop. So if j is less or equal to square root of a, it means that I have been in the loop. So obviously, so if j is less or equal to square root of a, it means that I have executed the break and the a number is not a prime, so there is no need to continue and do the second operation. So what I will do is that I will do the difference. So if j is strictly greater than square root of a, it means that I have finished the first loop and everything was okay. Now I can check whether b is a prime number. So I will copy this and move here. So again, I will loop from j equal to 2 to square root of b, and if j divides b, I will do a break. So whenever I'm doing a break, I will be out of the loop and I will be here. So here I should be able to know whether there's a divisor, yes or no. So again, I will check the same condition. So if square root of a is greater than b, so I have the negation of this condition. It means I have finished the loop. So obviously I have found two pairs that I need. So I found those two numbers are prime numbers. So what I need to do is that I need to print. So I will copy this and I will print a and b. So I can keep it I minus I, or I can print a and b as you wish. So those are my loops, so I will remove those and I will try to do that. However, we didn't yet check and do a printf for this case. So let's check. Let's see if the first test case passed. So I have forgotten to remove this printf. So I will recheck. So the first one passed. I have multiple tests that passes. So everything related to whenever I have a pair, I have reached to do it. However, whenever there's no pairs, I didn't print n. So what I should do here is that whenever there's no pairs, it means I have looped many times. So I have tried all the possibilities and there is no printing. So I need to keep track of whether I have printed something or not. So for that I will be using a flag. So let's call it printed. So first I will make it as low because I will not print anything, and whenever I print a pair, I will raise my flag. So this is a bit different. So I will start my flag as lowered because at first I didn't print anything. There's nothing to print. I don't have any pairs, and whenever I print a pair, I will raise my flag. So here, if my flag is still lowered, it means I didn't print anything. Now I can print f my character, which is equal to n. So this is a very important idea. So either we keep a flag or we keep a counter to count the number of pairs we have. So if we ask you to keep a counter, we just need to modify printed and make it increment. So we will increment it. So let's do it again here. So I will start from 0. So this is a counter, and whenever I'm doing a print, I will increment the number. So at the end, I can, so if it's equal to 0, I will print f, or else I will print f the number of pairs, for example, if the questions is about that. So because we can do that, so either with a counter or with as a counter or as a flag. So if the number of printing pairs, it will give me the number of pairs that we have found. So let's see here. So it should give me 2. This here 1. So we have an error, obviously, because this is not the same output. So we have 2 pairs, 1 pair. Obviously here I have no pairs. We have 6 pairs, and for example here we have 159 pairs. So we can use that also in order to find the number of pairs. So this is the solution. I will repeat it quickly. So obviously we will not use that. So we can keep it equal to 0, and we will not print the number of pairs. So as you have seen, so we have we have read a number, we have tried half of the numbers, and at each time I have checked whether A is a prime number, and if A is a prime number, I have checked if B is a prime number. However, as you can see, so I will show you an example, because you have already seen it here. So even if 4, or for example A is a prime number, B, it could be not a prime number. So I'll be looping mostly 2 times. So I have here an example. This is the same example here that we have seen. This is the 100. So those are the pairs. So in order to calculate whether those numbers are prime, obviously we have looped over square root of 3, 11, 17. So in the first case I have looped 1 times and then 9 times, and then we have those iterations. So what does it mean? It means I have tried here the numbers 1, 2, and 3, and I have tried here 1, 2, 3 till 9. As for here, I have tried the number 1 to 6, and then I have tried the number 1 to 7. So what I will do is that I will join both loops into a 1. So instead of doing 2 loops, I will do 1 loop. It will check at the same time whether the first number is prime and whether the second number is prime. So this is a bit optimized. So let's see how we will do that. So I'll be reading scanf, and then I need to loop obviously from i equal to 0 till n over 2, because I need half of the pairs. And then I need to check whether either A or B is a prime number. So if one of these is not a prime number, there is no need to continue. So in just 1 loop, I will do that. So I will remove all this, and I will tell you how we will proceed. So obviously I need to loop from j equal to 2. So till what? So if I'm looking well, which is the greatest number here? So obviously this number is the bigger. So n minus I, or B, is always the bigger. So I'll be looping till the biggest number, so square root of B, obviously j plus plus. And what should I do is that I'll be doing the division. I will be checking. So however, if you look well, I can, for example, check just the first 6 number here, not the first 7 number. So for A, I will not check all the values of J. So I will check the values that are admissible for me. It means from 1 to 3. So this is how we'll proceed. So if B modulo J, is equal to 0, it means this one, so the J divides the number B. Or we have A modulo J divides, so J divides A, but however, I should be sure that J is less than the square root of I. So because I have here, for example, 9, the square root of A is equal to 3, so J here, I should stop at the 3. I cannot check whether the number here, 11, is divisible by 4, 5, 6, because we don't need that. So the theory doesn't stipulate that. So if A modulo J, and so we can do that before. So J should be strictly or less or equal. So J, it should be less or equal to square root of A. So I should be sure about that. And A modulo J equal to 0. So if one of these is divisible, so if J divides either A or B, I will do a break to say that I have found a number that divides either A or B. So obviously this is not a good pair, and I need to do other division. So I will remove all this. So obviously I need to keep again a flag, because obviously I need to check if I have printed a number or not. So here, whenever, if I'm at the end of the loop, so if j is strictly greater than square root of b, so I have ended the loop normally, it means I have found a pair. So I will do a printf and I will raise my flag. So printf %d a comma b \n, obviously, and I will raise my flag to say, okay, I have found a pair. So let me repeat. So we have joined two loops into one. So we have looped over, so a is equal to half of the possibilities of n, and then I have looped over the biggest number. So obviously b, the square root of b, is bigger than the square root of a. It's 9, it's 7, so in all cases the square root of b is greater than the square root of a. So I have looped over the square root. So if one of these numbers, so from 2 to 9, divides 97, for example, I will do a break, so I will get out of the loop. Otherwise, so I will check also at the same time if the number j divides number a. However, so I can write this, but however, so j could be bigger than a, or the possible values of a can take. So I will not check, for example, here 9, 8, 7, 6, 5, 4, 3, 2, because the square root of 3, because as we have solved it at the first time, so we need to loop over the square root of a, so there's no need to loop from 2 till 9 and check all these. So we don't check those numbers whenever j is greater for 1 in here, or greater than 3, or greater than 6 here. So if I get out of the loop, it means one of the two numbers is not a prime number. And so if I finish the loop normally, so if the condition is false, it means j is greater than square root of b. It means I have found a pair, and obviously since I need to print n if there's no pair found, so I need to keep track if there's a pair was printed, I will use also a flag. So obviously, so what we have, so we need to use more loops, so I will use it here because they ask us to use 3 loops. So as long as is less or equal to 0, let's do a check. And obviously it passed. So I will remove a and b because obviously a and b, they are just I and n minus I. So instead of b, I will use n minus I. And instead of a, I will use I. So it will be more convenient. So I have just reduced the number of variables to just one number n and 2 counters, and a flag to check whether a number is, I have printed a pairs, yes or no. And obviously, so we have here 7, 9. I don't know how the 9 reached. So if I less than n over 2, square root n of I. Now obviously I have here, I should use a bracket. So I will solve again this, but without using a break. So just to know how to see and check and use other types of solutions. So this one will pass. So instead of flag, instead of break, I'll be using another flag. So let's call it divisible. So at first, I have this flag. So at each iteration, since it's a flag, I should lower it. So to say that I have, so for now, everything is okay. There is no number that divides my A or B. And whenever I'm reach here, so if one of J's divides either A or B, I will raise my flag. So whenever raising my flag, you can use a break also to say that, and then we can check whether divisible is equal to 0. So if I finish the loop and I didn't raise my flag, it means it's still lowered, and I can check this. However, I need to use a break. So you can, for example, you make this and use a break. However, I will not use a break here because I want you to learn new stuff. So I will loop as long as there's j is less than square root, and of course, and I will loop as long as I didn't find any number which is divisible. It means as long as divisible is equal to 0. So I will loop as long as I didn't reach the square root of the biggest number and there's none of these j's divided I or n minus 1. So this means divisible is different than 0. If I place not, it means divisible is equal to 0. So here we have replaced the break instruction with booleans. So this is useful whenever we have multiple nested for loops. So later in the course we will have more difficult nested loops, and sometimes we need not just to use breaks but to use also flags that will work also. So first at each iteration, so for each pair, since I needed to find whether those pairs are prime or not, so I have lowered my divisibility flag, so none of the numbers now divides my numbers I and n minus I, and if one of the j's divides I or n minus I will raise the flag, and obviously whenever I'm looping I will get out of the loop because the condition here would become false. So even if j is still less than the square root of n minus I, but here we have and, it means both should be true. However, divisible here, it means divisible is equal to 0. However, divisible now is not equal to 0, it's equal to 1, and I will get out of the loop. So let us pre-check one more time. And we have the correct solution. So this is it for this exercise. So we have solved it in 3 ways. The first way where we have checked whether both pairs are prime, so we checked them independently, first 3, and then we have checked 13. And if the first number was not prime, I didn't check the second prime, so it's a bit of optimization. So in the second attempt, so we have at the same time checked, because we are using the modulo operator over j, so we know, so we picked the number where j is the bigger, so obviously it's b, because the square root of b is always bigger than the square root of a. So, and we have looped over the square root of b, but we have also checked the divisibility of a until the square root of I. So if one of these number of j divides either I or n minus I will get out of the loop, either using a flag or using a break. So whenever I'm out, if I'm out normally, it means if I finished the loop normally, it means I didn't find any number that divides any of my 2 numbers. So I will print them on the screen, and obviously I have used a flag to keep track of whether I have printed a pair or not, because I need to print n if there's no pair. So it means if I've never entered this if, so I have used a flag, so it's always first it's lowered because at first I don't have any pairs to print, and whenever I am printing a pair I will raise my flag, and when I finish the loop, so it's out of the loop, whenever I finish the loop, if there is no pairs printed I will print n. So this is it for this exercise. So it seems very difficult, but it's very easy, especially if you know well how to do the calculation of a prime number. So this is it for this exercise. If you have any question, do not hesitate to write to me and I will answer you back. And do not forget to subscribe to my channel and to hit the bell icon to receive all the notification. And again, thanks for watching.